Hello students, welcome back. The next topic is break-even analysis. Previously, we discussed the cost, revenue, and profit function. We went through an example problem like this. Remember? Revenue, cost, both are linear models, and the profit is revenue minus cost. Simplifying, we get this. Now, what is the break-even analysis? That is, setting this profit equal to 0 and finding out x value. In other words, in this graph, we are looking for the x-intercept right here. When x is 5,000, we have this x-intercept here. That's when the profit is 0. So x is less than 5,000, profit is negative, y-coordinate is the function value, that's negative, and x is greater than 5,000, here, y-coordinate, the profit is positive. And right here at x equal to 5,000, that's called the break-even point. In general, the break-even point is defined like this. Profit is 0, or equivalently, the revenue is equal to cost. You see, R minus C is equal to 0. That means R and C are equal. Simple enough. Let's go to an example problem. Okay, here we go. A manufacturer sells a product for $10 per unit. The variable cost is $2.50 per unit, and the total cost of 100 units is $14.50. Oh, okay, I see. And the revenue is straightforward enough. The cost, on the other hand, has variable cost plus fixed cost, but the problem did not give you the fixed cost. You have to find it out. Now, once you find out, you have to do the break-even analysis. How many units must be manufactured in order to have break-even? That is, profit is equal to 0, or in other words, revenue and cost are the same. See? Basically, this is what we want. Profit, which is revenue minus cost, is 0. That's one way to do it. Or revenue equals to cost. So R minus C is 0, or R is equal to C. Either way it works. But in any case, we have to find out what is R and what is C. So how do you find out the revenue? That looks a bit easier in this case. $10 per unit, and I'm selling whatever unit, so 10x. Is that the revenue? Okay, alright. So revenue here, I'm going to plug in 10x. 10x here. How about the cost? The variable cost plus constant K, which is fixed cost. How about the variable cost? $2.50. That's the marginal cost, the slope. By the way, that's 10. The price. This is the marginal revenue, the slope. So the marginal cost is $2.50. That's a slope. So the variable cost will be $2.50 times x. And then plus k. This problem didn't give you that. But it did give you total cost of $1,450 for 100 units. From that, can you find k? Can you find it? Can you find it? Stop the playback and try to find out on your own. It'll be like this. That's your cost function. And x value here is 100. And that has to be 1450. So what do we have? We have all the numbers and k. So we have an equation of k. So what do you have? 250 times 100, 250 plus k equals 1450. So K is 1450 minus 250. That's 1200. Makes sense? So K, therefore, is 1200. And that's something you have to plug in right here, if you will, or right there, if you will. Okay, that was the outline of the strategy, and let's go to the solution. Solution number 1 is our textbook's method. And what we're going to do here is to set the revenue equals to cost. Let's see, revenue is simple, 10x. We went through that already, right? And cost function needs some work. Let's see, variable cost 250x plus k. You see 250 per unit, that's a marginal cost, so that's the slope. And that plug in x equals 100. That'll give you an equation of k. Once you get that equation, solving for k is easy. And then don't forget what you are going to do. You're going to set r equal to c to begin with, right? So don't get just carried away. Oh, I got k value, that's got to be the answer. Answer for what? We're just one step toward the answer, and there are several more steps to go. So k value is 1200. Plug it in, and we found out the cost function. So revenue is equal to cost. So setting these two equal to each other. So 10x, the revenue, is equals to this right hand side. That's the cost. Solving this equation, I'm going to get the x value, and that is the break-even point. Solving, you're going to get 160, so you have to have 160 items sold. By the way, in this problem, assume all items produced are sold. So we are not going to consider the inventory cost. There are some unsold items, and that you have to store those somewhere, and then that's inventory cost, and that's too complicated. And if you go to business calculus, we're going to deal with some inventory cost problem there, but not here. Okay, all right. X is 160, and in this case, what is the revenue? Just plug in 160 into this x value, and that's going to be, pretty simple, 1,600. Also, what is the cost? Plug it into this, do your computation. What a surprise, they're the same. Of course, that's by the design. They have to be the same. Revenue has to be equal to cost. Otherwise, something is wrong. That's one way to do it. Another way to do is to use r minus c is equal to 0. You see, revenue is 10x, and cost, well, the same idea. No. Variable cost plus fixed cost, and then when x is 100, we have 1450 from here, so for k, and we got the cost function. And then what do? Revenue minus cost. In other words, 10x subtracted by this. I call it backward. This is red and this should be blue. And that's this expression, 750x minus 1200. That should be equal to 0. So profit is equal to 0, solve it, and what a surprise, we got the same value, 160, of course. And then at this value, the revenue and costs are the same. We have a visualization here. Oh, okay, all right. Revenue function, r of x, and cost function, c of x, in the same viewing window. And then revenue, cost, and then they become equal to each other at the crossing value because they share the same y coding now. And that x value is around here to 160. Or here's another way to view it. R minus C and get P function, the profit function, and it's going to hit the x-axis because y coordinate is going to become 0 here, and that's 160. These two figures are actually identical, the same picture. I mean, they're not identical. They look different, but they're talking about the same information, identical information. Okay, so much for break-even analysis, and we are going to talk about section 2 in a separate video. Stay tuned. See you soon.